Now to the preparation of amines. The first method is called ammonolysis of alkyl halides. This is the reaction of ammonia with alkyl halides, leading to an aminium salt. The base treatment, or excess ammonia, forms the amine. Here, you can start with an alkyl halide. This will react with ammonia. Excess ammonia is required because the reaction produces an acid. This acid needs to be neutralized. The lone pair in ammonia is responsible for its reactivity. It will attack this carbon in an SN2 manner. And so you will produce ethanamine plus ammonium iodide. Now you may think this will stop here, but it will not. Ethanamine will still react with available ethyl iodide in solution, and so our process will continue. This compound will react again with ethyl iodide in an SN2 manner to form a secondary amine. It will continue further, reacting with your ethyl iodide to form a tertiary amine. It means that in this reaction, you can use primary, secondary, and tertiary amines and further alkylate your nitrogen. Now this will not stop here, it can continue further and form your quaternary amine. And so this reaction is often considered messy, even if the amine reagent is in excess. A more reliable method is the alkylation of azide ion, followed by reduction. Your alkyl halide can react with sodium azide. The azide ion has this structure. Now this azide can react by an SN2 process to form this alkyl azide. Reduction of this alkyl azide with metal-catalyzed hydrogenation or reducing agents such as lithium aluminum hydride will give you your amine. There's no further reaction in this case. You can follow the reduction of aromatic nitro groups as a method of preparation. Here you can put the nitro group to the benzene ring using our typical procedure. And when the nitro group is installed, this can be reduced to the amine. Typical reducing agents are hydrogen gas in the presence of a metal catalyst. This is catalytic hydrogenation, and iron or tin in HCl plus heat. One equivalent of hydrogen sulfide in alcoholic ammonia can reduce one nitro group in the presence of another, such as in this case. This reduction can be obtained in 70 to 80% yield. The most reliable method for preparation of amines is called reductive amination. Here you can start from an aldehyde or a ketone and react it with ammonia, primary or secondary amines to yield imines or enamines, which can then be reduced to form amines. For example, 2-butanone here can react with ethanamine at pH 4 to 5 to form this imine. We have discussed imines on the topic of aldehydes and ketones. This imine can be reduced by catalytic hydrogenation or a reducing agent to form a secondary amine. The typical reducing agent that can be used is sodium cyanoborohydride or lithium cyanoborohydride. These reagents are preferred because they can be mixed together with your amine and your aldehyde or ketone in the reaction mixture. Take note that you can also use sodium borohydride, but the problem with sodium borohydride is that it will also reduce your aldehydes or ketone to the alcohol. So sodium borohydride is only added after the formation of the amine. Sodium cyanoborohydride and lithium cyanoborohydride do not affect the carbonyl group. Amines can also be prepared by reduction of the nitroso group, nitriles, or oximes to yield primary amines. Amides can be reduced to yield primary, secondary, or tertiary amines. Again, the reduction can be accomplished using catalytic hydrogenation or lithium aluminum hydride. Monoalkylation of an amine can be achieved by acylation of the amine and then reduction of the resulting amide. For example, you can start with ethanamine and react it with acetyl chloride. This will readily form your amide. Reaction with lithium aluminum hydride plus an aqueous workup will reduce this carbonyl into the methylene, and so you will get your secondary amine quite easily. An old but still reliable method in making amines is called Gabriel synthesis. This can cleanly make primary amines. Here you will start with phthalimide and react it with a strong base such as potassium hydride to form potassium phthalimide. This reagent, however, is commercially available and you can buy in many reagent suppliers. Once you have your potassium phthalimide, it can be made to react with an alkyl halide in an SN2 manner to get this compound. Reaction with hydrazine or some other base can form the primary amine. Take note that secondary and tertiary alkyl halides are not effective in this method. This is a very strong base, and if you use, for example, a tertiary alkyl halide, it will end up in an elimination process.